Okay, students, I want to talk about the normal distribution. So an example here is my cell phone. And if I take apart my cell phone and I see my battery, these batteries last so much on a charge. Well, some charges are very short and some seems to last a long time. Now, I'm the type of person that leaves my cell phone on all the time, so I'm always concerned about that. Well, um, the times of the cell phone working would be am I going to do that? Okay, here we go. The time would be a normal distribution. Now, we need to talk about the standard normal curve. Now, why is that important? Well, here's an example. We were talking about heights of men, right? So the average man was 70 inches tall with standard deviation of 4. Let's just say the women were 60 and then a standard deviation of 3. The question I want to ask is which person's really taller for her group? That is actually a pretty good question. And the way we answer that question is we need to use the standard normal curve. If we use that, then we can realize that, let's see, the woman is 3 standard deviations above her mean, and the gentleman's 2 standard deviations above his mean. And that's really important. Now, I also want to point out a couple things about the standard normal curve, okay, or the normal distribution for a moment. The mean and the mode and the median are all in the middle here, and we're going to use this. We're going to put a 0 here, and then 1, 2, 3 standard deviations to the right. So that would be 0, 1, 2, 3, and then -1, -2, -3 for that part of the values to the left. So if you notice, 99% of the data, or percent, right? Percent of the data will be included to the left and to the right. Now that works for the standard normal curve. This is actually a big part of statistics. I hope you were able to get something out of the little movie on the homepage. Maybe you looked at that. All right, so we'll take a moment and we'll see this on the calculator. All right, very good. Okay, students, I have my calculator here. And here's my online calculator I'll use to explain how to do things in our class. These are my keys. Here's what I call my home screen, and here's what I call my key history, okay? So let's take the men's height problem and graph actually a normal distribution. Now, what this is a math formula that models the idea of a normal distribution. It's called the Gaussian distribution. What I want to do is just sort of show you some values by hitting trace. And notice 70 was at the median of the data, or the mean of the data. And as I go further and further to the right, notice the numbers of the values of the height are getting higher, but also notice that the height of the curve is getting smaller. So that is very interesting. Now remember, 74 was 1 standard deviation to the right. 78 was 2. And of course, 82 was 3 standard deviations to the right. Now, if you will notice here that the values are getting very close to the bottom line. So there's really not a lot that are way out there, but in theory, that graph continues in both directions. Also, something else that's interesting about the graph is it's symmetric, and this is curved, looks like a bowl, okay? It's curved this way, but then the curve changes its curvature. It's curved like a bowl, like it's a bowl upside down, okay? So this is a curve going increasing, and though it's increasing, it's starting to decrease, okay? Now it's curved down a little bit and then curved up a little bit like a bowl. So this is a very unique graph. And another thing that's really special about it, is that these positions where it changes that are also at the deviation, one standard deviation to the right and to the left. Anyway, that's an interesting thing. Another thing that's interesting is if I wanted to figure out the area under that curve, I could use a calculator to do it. And so from 66 to 74, notice this number 0.68. We have seen that before. So again, this idea of the normal curve, area under it is very, very important. Okay, remember the illustration of the woman and the man. We want to know who was higher compared to her group. Well, the standard normal curve enables us to do that. And believe it or not, there's a math formula. This is E. The base E is 2.718. And you could type that in your calculator. Let me just show you what it looks like. So here you go. This is the normal, the standard normal curve. And and you could tell we could hit the trace key, and as we go to the right, okay, sometimes I call it the Jack and Jill key, it goes up and down. Notice that we are going further and further and further to the right, and if we were concerned with the amount of data that's to the left of where we are, or the percentile, okay, we could figure that out. Now we could do it with this particular curve, and I'll show you a picture. So here I'm going to the z value of 1, and I'm showing you the area. Now remember, the whole area would be 1. So this area, 0.3356. This is very interesting there. Now students, that wasn't right about that picture. But this is illustrating the area under the curve. Now you can figure this value out by using a chart, by making a graph, or just by using a command on your calculator. And let's do that. So we're going to, I'm going to get out to my home page, and I'm going to go to second distribution. And we have some choices. I'm going to show you how to use number 2. So 2 is the accumulative density function value. The first value is -1 times 10 to the 99. That is very far to the left. For sure includes all the possible values. Let's just say the upper was 1, okay? And the mean was 0, and standard deviation is 1. So when you hit paste, it's going to paste it to your home screen, which is something some of you guys with the 83 can do, you know, without the little wizard here. But anyway, and that would be the value 0.8413. So hopefully that makes sense to you. And let's see, a little bit more about these functions. You're not going to use number 1 much, but number 3 you're going to use a lot, and that would be inverse of the normal distribution. Let's just do an example. Okay, so let's say the area was, I wanted to know 40%, and I'm going to use the standard normal curve, and I want to find out what this value is. And notice the z-score is -0.25. So if you had a z of -0.25, from all the way to the left to that point, you would have an area of 0.4, okay? Or a percentage would be 40%, or the 40th percentile, right? Okay, so that's some information about the standard normal curve. It's very, very important, and I hope this